Hey everyone, today we're going to be talking about multiplying polynomials, which is an incredibly important skill for us to go into um, as we reach into the second half of algebra. Multiplying polynomials is something that, well, if we can't multiply polynomials, then we can't get to where eventually we're going to go. Thankfully for you, most people get through this hurdle. Most people will get over it, and I'm here to make sure that you will too. So we're going to start off by multiplying monomials. And if you multiply a 1 and a 1, well, if you multiply it by 1, the shape kind of stays the same, basically. So 1 times 1, well, that's just going to be 1. Or if we want, we can just make that plus. Now, if we do a 1 times a negative 1, that's the way I think of it anyways. That's going to be a negative 1. Okay. And then a negative times a negative, well, we both know that that's going to be a positive. So we're not going to do everything here. We're just going to kind of cherry pick. Now, if I look at letter E, I've got an X tile, the long skinny tile, multiplied by a negative tile. So what that means is keep the same shape, but make the sign opposite. Okay. Same thing over here with the letter F. I've got a X tile and a unit tile. So the unit tile means we're going to stay the same shape, but we're going to make it negative because we have a positive and a negative. Where in letter G, same thing's going to happen. A long X tile multiplied by a small square, that's going to stay a long square tile, but since it's a negative times a negative, that's going to be a positive. Let's do some more of these. Now, if you have a X tile times an X tile, well, then that's going to change the shape. That's going to be a big X square tile. And since we have a positive times a negative, that's going to be a negative X squared tile. Just like when we have a negative times a negative, that's going to be a positive X squared tile. Okay, so the things to know is a small tile times a small tile, that's going to be a small tile. And then the positive or negativeness that's going to depend. But just like if you're multiplying positive 1, negative 1, or negative 1 and negative 1. The next thing that could happen is you could be multiplying a long square tile multiplied by a small unit tile, and that's just going to be a long X tile as well. And just like before, the positive and negative of the tile is going to depend on if you're multiplying one negative or two negatives or no negatives. And the last thing that we're going to look at is what if we multiply a long X tile multiplied by another long X tile? Well, that's when we get the large square X squared tile. Sounds confusing? Well, maybe it is, maybe it's not. This is not actually the way I look at it when I do algebra tiles. Here's my algebra tile set. And this says I'm going to be multiplying x plus 3. So here's my x plus 3. No, that's my x minus 2. Here's my x plus 3 over here. X plus 3. This is x plus 3. Notice we have got one x tile and 3 unit tiles. And then we've got an x minus 2. And that is one x tile and 2 unit tiles. But the thing I want you to notice is when you multiply this, you kind of, look what happens here. These divisions kind of stay in the same place. In between the tiles is the thing that I look for. And if I look in between the tiles, I actually get the correct shapes. And that's kind of fun too. Look at this one. We've got 2x plus 1. Let's see if we can figure out where that one is. 2x minus 1, sorry. Here it is, 2x and then a minus 1. And then a 2x and a plus 1. That's this one over here. And again, what I want to show you is that if you just kind of put the lines in between, everything turns out to be in the correct shape, which is the way that I normally do this. I just go ahead and draw my lines in between. Now we should talk about the signs here. Notice how this right over here, this tile right here is in the intersection of a negative tile and a positive tile. So a negative times a positive is a negative. And that's kind of where that comes from. Just like over here, we've got this tile right here. That's at the intersection of a positive tile and a negative tile. And that's why this tile is a negative tile. Okay, let's see if we can add all of this stuff together for my first one. I notice that I've got one big x squared tile, so I'm going to put that in there now. The x squared tile. Let's color that in. And then I'm going to look at the x tiles, and I notice that I've got some positive ones and negative ones. So this one over here, the negative tile, is going to make a zero pair with that positive tile. And this negative tile is going to make a zero pair with this positive tile. And then the only thing I have left is this one x tile. So this is going to be plus that lonely x tile. And then the last tiles I have left, now these don't have any zero pairs, so they're just going to stay. That's 1, 2, 3, 4, 5, 6 of them, and they are negative tiles, so this is plus a negative 6. Let's do the same thing over here for letter B. We'll start off with the x square tiles. Let's get rid of that. And the x square tiles are, we've got 1, 2, 3, we've got 4 of them. So that tells me I have 4, tiles that are the shape of x squared, so 4x squared. And they're positive, so plus 4x squared. Plus. Now let's see. I already see some zero pairs. This is a zero pair with this. This is a zero pair with a positive one. So there's actually no more x's left, so I'm not going to bother writing it. But I do see there's a lonely negative 1 tile over here. So plus a negative 1. And that's going to be the end of that. I'm going to try letter D. And in order to do D, I'm going to go with my method, and I'm just going to draw the lines straight up and down. So in between every tile, I'm going to draw a line that goes straight down. 2, 3. Okay. And then in between each of these, I'm going to draw a line across. I got to be careful to draw them kind of straight. Okay, that kind of does it. And now we got to figure out positive or negative. So this over here, this is at the intersection of a positive and a negative tile. So a positive times a negative is a negative. This tile over here is at the intersection of a negative tile and a negative tile. So this is a positive tile over here. The next tile I'm going to look at is this one, which is at the intersection of a negative and a negative. So this is going to be a positive tile right here. Likewise, we've got at the intersection of a negative and a negative. This is going to be a positive tile. In fact, for this entire column, this is going to be a positive times a negative, so that's negative. Positive times negative, so that's negative. Negative times negative. Negative times negative, etc., etc. And then let's see what we've got. Now the biggest shape is this negative x squared tile. So I'll put a negative x squared here. Negative x squared. And then I'm going to take a look and see I've got zero pairs. This guy is a 0 pair with this guy. This positive x is a 0 pair with this negative x. And I'm just left with one lone positive x tile. So we're going to say plus a positive x tile. And then I'm going to say how many of the unit tiles do I have? I have 1, 2, 3, 4, 5, 6 unit tiles, and they are positive. So plus a positive 6. If you want to clean that up, of course, that's going to be negative x squared plus x plus 6. Now I know that method's not for everybody, and it frankly does take a long time, so it's usually worth it for us to kind of move beyond this. But you can always come back to these algebra tiles if you need to go back to basics. So the way that we learn this, or the way that we try to make this faster, is something called the FOIL method. Now in the FOIL method, the FOIL is actually an acronym. It stands for first, outside, inside, and last. So the method is, if we take a look at the first terms, okay, that's going to be this term and this term, because they are the first terms in each binomial. And make no mistake, multiplying two binomials is actually a really important part of algebra. So we're going to do this over here. Now I know it says use the distributive property, but we're going to be multiplying our binomials like we normally do with the FOIL. So let's copy our notes over here so we can know which ones to do. And first of all, it says to do first. So which are the two monomials that are first? Well, they are the b, I'm looking at number 2, and the b. So b multiplied by b is b squared. How about the outside? Okay, the outside is going to be this b and this positive 2x. I'm looking over here. So that is plus 2x, or 2b. So we'll put a plus and then a 2b. Next, the inside. Which ones are on the inside? Okay, and according to what I see, they are in the middle. So it is a minus 3 and it is the b. So if I add those, multiply those two together, I get a plus. Of course, I always put a plus in between, a minus 3b. Now the last one is going to be, well, last. So what is last here? It's going to be a minus 3 and a plus 2. How much is minus 3 plus 2? Is that negative 6? My fact checkers say that that's negative 6. Okay, so negative 6. Let's combine terms together. We've got a b squared, of course. That's going to be fine. A 2b and a minus 3b. That's the same thing as 3 minus 2, but opposite. So 3 minus 2 is 1. Opposite is minus 1, so minus 1b. And then, of course, the plus and minus 6, that's just minus 6. Of course, you don't actually need the 1 here. That's kind of extra. And we've done it. We've FOILed together. Let's do the next one. I'm going to take my notes and keep them with me. So letter number 4, let's do the first. That's a times 2a, that is 2a squared. Let's do the outside. That's a and 5, so that is 5a. Let's do the inside. That's minus 1 multiplied by 2a, so that's negative 2a. And last, that's minus 1 multiplied by positive 5, or just minus 5. Okay, so we have done all of the FOIL. Now we just have to combine things together. Clean this up, make it look nice. 2a squared, 5a plus negative 2a, that's 5 minus 2, or positive 3. And then plus a minus 5, that is minus 5. There is my FOIL. Let's do the next one. Here we go with number 6. First, outside, inside, and last. And then we're going to put things together. That's 3r squared plus 2r plus 9r, that's 11r, and then plus 6. There we go. Now the next skill says to use a table to find a product. Now when you use a table, this is going to be a lot like using the algebra tiles, but without the actual algebra tiles. So let's take our first term, x minus 3, and then we're going to place it along the side. And then we're going to take x minus 2, and then similarly put the numbers in the chart. And then now we just got to kind of multiply like a lattice. We've got x times x, that's x squared. We've got x times negative 2, that's negative 2x. On the second row, you've got 3 times negative x, negative 3x. And then finally, negative 3 times negative 2, which is a positive 6. Now that you have the lattice all written out, you can just write each of the interior monomials here. You got a plus x squared plus a negative 2x plus a negative 3x plus a 6. So we're just turning them out. And then we can combine like terms. You got a minus 2x and a minus 3x. That's a minus 5x. So that gives us x squared minus 5x plus 6. Some people really like this. I'm pretty good with this one. Let's do number 8. Y plus 1, y minus 6. And now we can start multiplying things together, starting with y times y. Y times minus 6 is minus 6y. 1 times y plus 1y. And then finally negative 1 times negative 6. That's just negative 6. And now we'll just write everything out. So y squared plus negative 6y plus positive 1y plus negative 6y. And we have the opportunity to simplify these terms in this center here. That's a minus 6y and a positive 1y. That is a minus 5y together. So y squared minus 5y minus 6. That takes care of our multiplication. Let's see, we've got a couple more to do here. Let's try and do them really fast. Let's do this first one. You've got 6h and a minus 2. We've got a minus 3 and a minus 2h. Actually, I don't like the way that looks. I'm going to reverse that order. I'm going to put a minus 2h here and a minus 3 over here. So let's multiply things together. 2h times 6h, that's 12h. So minus 12h squared. You've got a minus 2 multiplied by a minus 2h, so that is plus 4h. Over on the second row, second column, we've got 6h times negative 3, that's negative 18h. Minus 3 times minus 2 is plus 6. Let's turn everything out. Minus 12h squared minus 18h plus 4h plus 6. And then these two center terms get to be simplified together. So minus 12h squared. Let's see. 18 or 4 minus 18. That's like the opposite of 18 minus 4, which is 14. So negative 14h and then plus 6. See how quickly these kind of get done? Okay, 12. Last one we're going to do. We've got a minus 3 and a plus 4j. And again, I don't like the order of that. I want the j to be first. So let's put the plus 4j on the top and put the minus 3 on the bottom. Then we also have a 3j and a plus 4. Let's multiply the first row. 4 times 3 is 12. J times j is j squared. 4 times 4 is 16, so 16j. I wrote a y accidentally. My bad. Let's put a j there. Okay, second row. Negative 3 multiplied by positive 3j. That's minus 9j. And then minus 3 times positive 4. That's minus 12. Okay, 12. I'll show you the trick here. 12j squared I'm going to write first. And then I'm going to take a look at the diagonal squares here. They have the same term. Okay, they are the same monomial. So 16 minus 9 is, what is that, guys? 7 plus 7j. And I forgot my square here. And then my minus 12 just gets flipped out like that. Okay, so that was kind of done at varying speeds. Hopefully you got better at this as we went on. Let's see. Oh, we've got even more. So let's use the foiling method here. The first, that's z times z, which is z squared. And then the next is going to be the outside. Outside is going to be z times positive 2. So that's plus 2z. The inside is plus 3z multiplied by 3, which is plus 3z. And last is plus 3 times plus 2, or plus 6. I can combine plus 2z and plus 3z to make plus 5z. So my answer is z squared plus 5z plus 6. Let's go ahead with 17. Same idea. First outside, inside, last. 4n times 3n is 12n squared. 4n times plus 4, that is plus 16n. Minus 1 times 3n, that's minus 3n. And then minus 1 times plus 4, that's minus 4. We can combine these two terms right here because they both have an n. So you got 12n squared. 16 minus 3 is 13n, and then minus 4. And then finally, we're just going to do one of these. We're going to be multiplying this product. And this kind of works a lot like distribution. So what I'm going to do is I'm going to take this 2 and I'm going to distribute it to everything. So this is 2 times 3a. That is 6 a squared. Then I'm going to do 2 times 3a, and that is 6a, so plus 6a. And then I'm going to do 2 times minus 5, that's minus 10. And now I've multiplied this 2 by every other thing inside this trinomial. So now I'm going to multiply the minus a. How much is this minus a times 3a? Well, that's minus 3a cubed. Now how about minus a multiplied by 3a? That is minus 3a squared. Okay, and the last one is minus a multiplied by minus 5, and that is plus 5a. So now this is going to be where our skills of combining like terms is really going to come in handy. So we're going to look for the highest power. Let's scan. I see the highest power is 3. And there's only one monomial with a 3, so we're going to put that first. Minus 3a cubed. The next highest power, it's got to be 2. So there's a 6a squared. There's a minus 3a squared. How much does that make? Plus 3. So yeah, plus 3a squared. The next thing is going to be a to the first power. There's 6a to the first power. There's 5a to the first power. So how much is that? 6 and 5 is 11. And lastly, we have all of the constant terms, and oh, there's only one of them, minus 10. So let's put it over here, minus 10. Ooh, that was interesting. Okay, minus 10, and now we're going to clean it up. Minus 3a squared cubed plus 3a squared plus 11a minus 10. And that's going to do it for us. This turned out to be a pretty long one, but this is a very important skill. We're definitely going to be looking at more of this next time. So have a good one. Good to see you all, and enjoy your algebra. See you next time.